r1 square, the integral solution will be r1 square plus r2 square minus 2r1 r2 and cos theta 2, and this whole will be in the power of half, because minus half plus 1 will become half, and then this whole will be divided. Whatever will remain will be r1 and r2 here. So we have the solution of the integral like this, and then there are the limits from 0 to pi. So first we will put the limit, when this thing comes out to be equal, the limit we will put pi. So cos pi is equal to minus 1. Minus 1 will make this thing plus. So we will have r1 square plus r2 square plus 2r1 r2, and inside a square root, then minus, and cos 0 is 1, so it will come out to be r1 square plus r2 square minus 2r1 r2 inside a square root. So we have this thing, and then this whole will be divided by 1 over r1 r2. Now I can further write this thing is, as I know that this one is r1 plus r2 whole square, while this one is r1 minus r2 whole square. So the square will cancel easily with the 1 over 2 there, and I will get that this integral 1 over r1 r2 comes out to be r1 plus r2 and minus r1 minus r2. And here we are. Now if I look at the geometry, from the nucleus, the distance of one electron is r1, while the distance of another electron is r2. Now we are not recognizing the electron, so we are not sure about whether r1 is greater or less than r2 and vice versa. So for this reason, we will have to put some conditions. Let's say, for example, here it doesn't matter if r1 is less than r2 or, but here it does matter. Look here. If r1 will be greater than r2, then this whole will be positive, and when it come outside, it will become negative. If r1 will be less than r2, then this is negative. When it will come out, it will become positive. So different expression will occur here, and let's say we say that for 2 we are going to calculate this thing. So this is 1 over r1 r2, and let's say we first do approximate this thing like r1 is greater than r2, or we put the condition on r2, because as we are doing the integration on r2, so better to put this this limiting case on r2. So this will be 1 over r if the situation that there will be, let me write this thing in a different manner here, and that will be, let's say, let me write this thing like this, that this is equal, let me write 1 over r1 r2, and here I do write r1 plus r2 and minus r1 plus r2. R1 plus R2. Now what situation will be this one? When R2 is less than R1. Because when R2 is less than R1, then this will be in the same setup, and we will have minus R1 and plus R2. While 1 over R1 R2, this is equal to R1 plus R2, and when the situation will be that R2 will be greater than R1, then the whole term is supposed to come this way, and we will write the absolute here, so it will become plus R1 and minus R2, plus R1 minus R2, because its whole will give you a negative, and that negative will be reflected there, and this will be for R2 greater than R1. Now in this situation we will have the two things here. Now in this one, R1 and R1 are cancelling, and we have 2R2. 2R2, R2 will cancel, and what we will get? We will get this thing. Okay, whatever is here, let me leave this thing here. So this implies that I2A is equal to, this will become 2R2, so R2 will cancel, so 2 over R1 if R2 is less than R1, and 2 over R2 if R2 is greater than R1. So it depends, means both the conditions are possible. So we have this thing equal to this, and now this is basically the solution we found for theta. This is the theta 2 solution that we found. So now we will put this solution back to this equation where we have found the theta value only. So I can write that this thing is equal to, from there I2 will become equal, I2 will become equal to, from here, the integral. Now before the integral, 2 over R1, 2 over R2, so 2 is common in both. So this 2 we will move outside. And another thing, phi will give 2 pi. So 2 pi and 2 pi will become, 2 into 2 pi will become 4 pi, and then we have the integral, and now the integral, the first integral, which will be on R2, first we will move it from, means the integral is on R2, so first R2 we will move it from 0 to R1, and then from R1 to infinity, the limits of the integral. So here from 0 to R1 and e to the power minus 4 R2 over a, and then it will be, it is here R2 square, so R2 square is coming in, R2 square divided by R1, R2 square, and then 1 R1 from here. So means this is the situation when R2 is less than R1, means for that situation, so R2 will only rise from 0 to R1 here, so R2 square, and this is 1 over R1 here, 1 over R1 and then dR2 and plus when R2 is greater than R1, so it means it will start from R1 to infinity. It can reach to the maximum, the highest possible value, and that is infinity, from R1 to infinity, and e to the power minus 4 R2 over A, and this is R2 square, and this will be 1 over R2. So it will simplify, 1 R will simplify, and then dR2. So we have the I2 integral is this one. So we split it. Why we split it this one? Because we splitted this one, as we found the theta solution, then the theta solution came out to be 2. So we splitted this integral into 2 because their limits are different. One is R2 is less than R1, so it means it will only range from 0 to R1. The other is that R2 is greater than R1, so it will start from R1 and it can reach to infinity. So we splitted this integral. The phi we already wrote here, 4 pi here, why it is 2 pi, and then 1 2 is coming from here and here, so this will make this thing is equal to 4 pi. Now there is we will have now to solve this integral, and this integral we are going to solve first. This is R2 square over R1. This will become R2 square. 1 will simplify with this, and we will have the value of this. Now I can call that solving this integral, it will be I2, and I can call this, instead of B, even I can call AB. The A I have utilized here, so this I can call to B, and this integral is 2C, I2C, and we will solve this integral in order to get I2. When we will get I2, then that I2 we will have to put in the integral which we have for R2 as well. Means when I2 will be solved, this is I2 integral, then this I2 integral we will put back over here, and we will solve this final integral then. Now what are the solutions? I will write the solution of this integral in this integral directly, but when you will open the lecture notes, in the lecture notes I have solved this thing step by step. First I plan to do solve this thing in a lecture, but the lecture length was increasing enormously, and we should focus more on the topic, the concept behind the topic, while the calculation we can make shorter by just including them in the notes.